combination of capacitor. Two or more capacitor may be connected in number of ways. The combination should have 2 points which may be connected to a battery to apply a potential difference. The battery supplies positive and negative charges to the system. If V be the potential difference, let V is potential difference between the points, and Q be the magnitude of charge, and here Q is the magnitude of charge, is your charge supplied by either terminal of battery. We define equivalent capacitance of the combination between 2 points is equal to C is equals to Q by V. Here the given connection is in series connection. Here in series connection charges will be same, that means at all capacitor charge will be same. Here in series connection, charges will be same on each capacitor. Here there are 3 pairs. First one is, let this plate is A1, this is A2, this is A3, this is A4, this is A5, and this is A6. That means there are total 6 plate and 3 pairs, and this is your positive charge on this plate. Let this is positive charge, this is minus Q, and here plus Q charge, again minus Q, here again plus Q, and here minus Q charge on the your individual plates. Here let potential is V, and here potential will be, here let V1, and here potential will be your let V2, and here potential is let your V3, and let this point is P, this point is P, and this point is here N. That means you can say here Q is equals to, for this capacitor first plate is A1 and second plate is A2. For this capacitor you can write, and the potential difference is V minus V1. So you can write V minus V1 is equal to Q by C1. Similarly, for second capacitor you can write, here potential is V1, here potential is V2. Always remember, in series potential will be different and charge will be same, and here V1 minus V2 is equal to again Q by C2. This is, here capacitance is let C2, and here V2 minus V3 is equal to Q by C3. Adding all, this is cancel out, this is cancel out. V3 is here 0. V3 को हम क्या किया है, zoom कर लिए हैं, ये 0 है because ये बैटरी का हायर पोटेंशियल है, this is lower potential. Lower potential के लिए potential 0. So here V minus V3, that means V minus 0, that means V is equal to, adding all you will get Q by C1 plus Q by C2 plus Q by C3. That means V is equal to Q common, that means this is V 1 by C1 plus 1 by, this is C2 plus 1 by C3. That means you can write V by Q. V by Q को हम क्या लिख सकते हैं, Q equals to CV, so 1 by C equivalent, and this is 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula for equivalent capacitance if capacitor are arranged in series. Here question is, calculate the charge on each capacitor shown in the figure. Here 20 microfarad and 20 microfarad capacitor are arranged in series, and here potential is 30 volt. The two capacitor are joined in here series. Their equivalent capacitance is equal to 1 by C is equal to 1 by C1 plus 1 by C2. That means you can write C equivalent, LCM लेने के बाद आप लिख सकते हैं C equivalent is equals to C1 into C2 divided by C1 plus C2. That means you can write here capacitance is 20 microfarad. 20 microfarad, that means here C equivalent is equal to 20 into 20 divided by 20 plus 20. That means this is here 2 into 2, 400 divided by 40. That means you can write this is 10 microfarad. The resultant is here 10 microfarad. The charge supplied by the battery is equals to Q equals to CV. So C is here 10 microfarad and into this is 30 volt. You can multiply. This is equal to here 30 and this one is your 300 microcoulomb charge. This is microcoulomb charge will be here. In series combination, each capacitor has equal charge and this charge is equal to charge supplied by the battery. Thus, each capacitor has charge 300 microcoulomb. Now, parallel combination. This is parallel combination. Here, 3 capacitors are arranged in parallel. This figure shows 3 capacitors connected in parallel. The capacitance are C1, C2 and C3. The point P and N, here this is let point P and this is N, are the point through which potential difference can be applied and charge can be supplied. Let us connect the point P to the positive terminal of battery. This is positive terminal of battery, and N to the negative terminal of battery. This is here negative terminal of the battery. Here in parallel combination, here potential will be same. In parallel combination, potential will be same. Potential will be same and your charges will be different. So you can write here using the equation Q equals to CV, you can write Q1 is equal to C1 into V because potential is same. So this is equation 1, and Q2 is equals to here C2 into V. Here potential V potential. Here charge on plate A1 is Q1 positive, this is Q1 negative. A2, this is Q1, Q2 positive, Q2 negative. This is plate 3, A3 and A6, Q3 positive and Q3 negative. And third, Q3 is equal to C3 into V. This is equation 2, this is equation 3. And here you can write Q is equal to Q1 plus Q2 plus Q3. That means you can write Q is equals to, तो Q1 क्या लिखेंगे? Q1 is here C1V, Q2 is C2V, Q3 is C3V, and Q is equals to, you can write CV. V is here same, and C is C equivalent. That means C1V plus C2V plus C3V. V cancel out, कॉमन लेने के बाद कैंसिल कर देंगे. That means you can write C equivalent is equal to C1 plus C2 plus C3. That means you can write C equivalent is equal to C1 plus C2 plus C3. This is the formula for parallel capacitor. Question is, find the equivalent capacitance of the combination shown in the figure between the points P and N. Here 10 microfarad and 20 microfarad capacitors are connected in parallel. So their equivalent capacitance will be 10 plus 20, that is 30 microfarad. That means you can write here, this is 30 microfarad and this is again 10 microfarad. This is 30 microfarad. This and this one is in parallel, and for parallel capacitor here C equivalent is equals to C1 plus C2. That means 10 microfarad plus 20 microfarad is equal to 30 microfarad, and here the equivalent capacitance of this two capacitor, and this is here 10 microfarad, and here this is the connection with battery. This is P and this is Q. Now 30 microfarad and 10 microfarad are in series, so equivalent capacitance you can evaluate. Now you can solve this. Here two capacitor are in series, that means your formula is C equivalent equals 1 by C1, that means 30 plus 1 by 10. Taking LCM, this is 30 and this is here 1 plus 3, that means this is 4 by 30. That means C equivalent is equal to 30 by 4, that means here 15 by 2, that means 7.5 microfarad is the equivalent capacitance between P and Q of this circuit. Here equivalent capacitance is 7.5 microfarad.